continue from the previous video where we define why we got sigma x, why sigma y, but tau xy, and what is the x plane, y plane, positive x plane, positive y plane, etc. And now let's move on to the stress transformation. So that, as I said earlier, it with known state of stress, which is the sigma x, sigma y, if we have an angle moving that block to an angle theta. For example, here, if we have a cut, any random cut through that block, let's write clear here, through the blocks. And the angle theta is defined from the x plane to that block. Okay, x plane to that block. So that angle theta is basically that angle from the x plane. So positive or negative, it should be the same because it parallels. So it will be theta. That is the angle theta we are talking about by definition. Angle theta. And when it angle theta, it will have from the axis, and the axis here, as you can see, it become the, let me draw it down here first. Draw down that the bottom part of that block, it will be something like here. And you have the new plane that you cut through and form an angle theta at that point. Then on this side we have here is sigma x, and then of course that is the tau xy going down here, tau xy, and on the bottom, which is the negative y plane, horizontal plane, there we have it tau, and then the sigma, and in this case sigma y, because equilibrium sigma y go up on the positive y plane, it have to be sigma y going down with the same magnitude. And we want to look at, with that transformation, I want to look at what is the with new plane here, what is the sigma for this plane, call it x apostrophe, and what is the tau for that direction. So on the x apostrophe plane, in the y apostrophe direction, what is that? Look at in this point, in that notation here. So we have the angle theta rotate, so we have that x apostrophe from an angle theta, this is x apostrophe, and that x apostrophe from an angle theta from x, and then the y apostrophe of course have to be orthogonal to the x apostrophe, so it become y apostrophe. So we want to find out what is the sigma x apostrophe, tau x apostrophe, y apostrophe, and of course sigma in y apostrophe. So with that, for the stress transformation, we want to determine new state of stress, oriented angle theta from initial coordinate system, which is x and y, from initial coordinate system. So what does that mean? We want to know what is sigma x apostrophe, sigma y apostrophe, and tau apostrophe and y apostrophe. So when we form an angle theta in there. So let's work on this with the stress transformation. With the stress transformation. Now it really go to, with that setup, we can be able to go to the stress transformation, the main topics for today class, stress transformation. So just go to put that block into 3D, So let's put that block into 3D. So what do you have here is the block up here. .3D. And if we call the angle that we just saw there with that block here theta, then that angle here is theta. Angle here theta. So from that, if we call the area on the inclined plane here, that plane that form an angle theta, that is dA. So differential areas. Then with that theta defined in there, you can see the opposite, which is the bottom area here. We can have it dA sine theta, the bottom. And then we can also have the back area there, that is dA cosine theta, because it's adjacent to the angle theta. So that what is your good trigonometric. So from that, what do I have here? Let's rewrite that block in there. So let's make it bigger block, so we can be able to see that. So it have block here, make it bigger in 2D with angle theta there, and you have on the note there, we will have, and with the sigma x apostrophe in that, and if with the area delta A, so we can have the sum of the products of the sigma with the areas, it becomes the force, right? So you have that one, force paralleled, and that equal to sigma x apostrophe dA. And of course, similarly for the tau xy apostrophe, so we have that is tau x apostrophe y apostrophe dA. And similarly, the bottom, you have it tau xy sigma y, and now if we put the force, we have to time the areas, stress time the areas, you get the load, right, or the force. So from there we can have tau xy dA, and that area at the bottom is dA sine theta, so we can put it dA sine theta there. And of course that one, it will be the similar, it will be sigma y and you can see from there time the bottom areas with dA sine theta. And of course, similar for the vertical plane on this side, we have that is sigma x, and the vertical, so it's the back area dA cosine theta. So we can have that is dA cosine theta. And then the shear going down here, for the shear force, it will be tau xy dA on so cosine theta. So we have all the forces. Put the stress from here time the areas from the box there, we can be able to find out the free body diagram basically for this block when we put the force in. So with that, we sum up all the force in x and y direction, and in this case x apostrophe. What do we have? And now let's do that. Continue. Let I sum up all the force in x apostrophe direction, and I assume go that is positive, and of course for equilibrium that have to be equal 0, and from that we can just break it down with your good projection here. So 0 on the left, I can have the sigma x apostrophe dA, the tau x apostrophe y apostrophe dA cancel because that perpendicular to the x apostrophe axis. And similar for that, we can have write down for the bottom plane. So you have it negative tau xy dA sine theta. That's what you have. And it from the angle with that one, it angles will be cosine for the x apostrophe. So we have that one time cosine theta because we project to the x apostrophe direction. The force, in parentheses, is the force at the bottom time cosine theta to get the component for the x apostrophe of the force. Similarly, let write down. So the other one, you have sigma y dA sine theta, that is the force, and then it sine theta to project that in x apostrophe direction. And then you also have on the vertical plane, which is sigma x dA cosine theta and tau xy dA cosine theta, we also have that as well. So we have it negative the force time tau xy dA cosine theta, and the to make projection that become a sine theta. And the last one negative because we assume go up in positive x apostrophe direction is positive. Negative sigma x dA sine cosine theta, and then we also have it cosine theta for the projection in y direction.